Let us now familiarize ourselves with the pages of the nautical almanac that contain the star information. We have these two pages showing up on the screen. We have the first column of magnitude. Next one is the name and number of the star, so names and number of the star. And then we have this SHA and declination month-wise from January to June on the left page. And for the same set of stars on the right side page, the SHA and declination information is from July to December. Now, stars listed on these pages are listed in the increasing order of their SHA. So the SHA is increasing here, and stars are listed in the increasing order of the SHA. 57 stars used for navigation are numbered. These 57 stars which are used for navigation have been numbered here separately. You can see some numbers against those stars. And the number of the star is decreasing as the SHA is increasing. Now on the left hand side and right hand side, it's the same set of stars, but you can see the names they appear to be different. Now the names on the left side are the Latin names for the star, and the names on the right side are the English names for the stars. Now here you see, this is the Latin name of the star, which is circled, Alpha Lyrae, which is star number 49 with a magnitude of 0.1. Now the same star, when seen on the right hand side, it's Vega. So therefore, Alpha Lyrae is the Latin name for Vega. When we give our answers, we'll be using the English names.
Beta, you can see all these figures in your table here, page 268. So just have a look at it and let me know if there are any doubts.
मतलब सर सब कुछ सेम है, बस इंग्लिश नेम है अपने राइट हैंड साइड में, लेफ्ट हैंड साइड में लैटिन नेम्स हैं, बाकी सब डाटा उनका मतलब मंथ वाइज दिया हुआ है, बाकी सारा डाटा.
That's right, beta. The stars are the same. Left side Latin names, right side English names. For our purpose, our examination, we use the English names. So even if it is the month of January, you will use this highlighted stars as Vega and not as Lyrae.
Okay, sir.
Understood, beta?
Yes, sir.
Okay. और बेटा और कोई डाउट?
सर ये पूछ रहा था कि सर नेम ओनली इंग्लिश है, डेटा भी चेंज है उसका?
बेटा लेफ्ट साइड में जो डाटा दिया हुआ है दैट इज फ्रॉम जनवरी टू जून. सो SHA and declination in the month of January up to the month of June is given on the left hand side page. The declination and SHA from July to December is given on the right hand side page. So that is the data which is provided, and the names are written on both the pages. They may look different because left side are Latin names, right side are English names, but the star is the same.
Okay sir.
Okay. और बेटा और कोई डाउट?
स्टार नंबर पे क्या होता है?
ये जो यहाँ लिखे हुए हैं बेटा 57, 56, 55 these numbers?
Yes sir.
Okay, they are not required as far as our purpose is concerned. What these numbers are, I'll tell you. Some of the stars which are very frequently used for navigation purposes are mentioned on the daily pages, the date pages. अब ये जो stars mentioned हैं date वाले pages पे, these are the ones which are numbered here. Total 57 stars are there. You can open your almanacs, any daily page, date page, and you will be able to see it. Just have a look, beta.
Yes.
Yes sir, वहाँ पे भी SHA और declination दिया हुआ है राइट साइड पे.
Very good. So these are the ones which are numbered here. Not required as far as our purpose is concerned. We will not be using this number anywhere.
ओ
Okay. और बताओ बेटा.
आंसर जो SHA और डिक्लिनेशन के बीच में दिया हुआ है नॉर्थ 77 डिग्रीज नॉर्थ 15
Beta, look carefully. The SHA and declination values under the month column are given only in minutes. Degrees are given at the beginning. Did you get it, beta?
यस सर
Okay. Or beta, any more doubts? All clear up to here, beta?
ये पेज
Yes,
के
sir.
लास्ट में जो 3.0 to 3.7 डबल एरो बना हुआ है सर, इसका मतलब क्या सर?
Where, beta?
In the bottom of the page, sir, bottom of the page on the left side.
ओके. अब बेटा ये जो स्पेशल सिंबल बनाया हुआ है इन्होंने, डबल एरो और प्लस और डबल प्लस, देयर विल बी ए स्पेशल सिंबल. अगर आप ऊपर लिस्ट में देखोगे तो किसी स्टार के अगेंस्ट वो स्पेशल सिंबल लिखा होगा इन द मैग्नीट्यूड कॉलम. लिखा हुआ है कहीं पे, देखो.
Yes sir,
लिखा हुआ है
particular इसमें
सर,
लिखा हुआ है.
ये अपना 101
लिखा हुआ है।
101
राइट.
ये क्या है? हाँ, ये लिखा है.
राइट. सो अब ये जिस भी स्टार के आगे ऐसा स्पेशल सिंबल है, you look for that symbol at the bottom, it will give you a range. It basically means the magnitude of that star is changing, it is variable, and it could be
Variable.
any. बोलो बेटा. Are you able to hear me, beta?
Yes sir,
Yes
yes.
sir.
Okay. So ये जो special symbol है, it gives you a range of magnitude. The magnitude of that particular star is variable. It is changing, and the magnitude could be any value between these two figures. That is the meaning of this special symbol. Understood, beta?
सर
Got it?
हमें ये वैल्यू लेनी होती है सर, अगर यूज करनी है वैल्यू तो मतलब कौन सी वैल्यू?
राइट बेटा, राइट. अगर हमें क्वेश्चन में वो कोई स्पेसिफिक स्टार निकालने के लिए बोलेंगे तो हमें ये जो रेंज दे रखी है इसको कंसिडर करना पड़ेगा. दैट आई विल टेल यू हाउ इट इज कंसिडर्ड.
ओके सर.
ओके. और बताओ बेटा, और क्या डाउट है? All clear up to here?
Yes sir.
Okay, all right.
Let's quickly revise the parts of the familiar PZX triangle.
So this is the same PZX triangle which we had already discussed. Now we have seen the star table, we are familiar about the twilight, we are familiar about the concept of magnitude. So we are revising the PZX triangle here. Only thing is I showed you the PZX triangle in the complete rational horizon diagram. Here it is explained only using not the full diagram is shown, only the PZX triangle is shown here, but it is exactly the same what we had discussed. So let's revise it.
We all have seen this PZX triangle many a times, in which P represents the celestial pole Z represents observer's zenith, and X represents the celestial body. In this side PZ, which is arc of observer's celestial meridian, is called as colet and is always equal to 90 minus latitude of the observer. Side PX in this, which is arc of the meridian of body X, is called as polar distance and is always equal to 90 plus minus declination. Side ZX, which is arc of observer's vertical circle passing through X, is called as true zenith distance and is equal to 90 minus true altitude. Angle P is called as R angle, and in this case, as the R angle of the body is measured eastwards of the observer, this R angle is called as EHA, that is easterly R angle. Angle Z has some relationship with azimuth. In this case, the azimuth will be measured clockwise from true north, and we see that in this particular triangle, yes, angle Z and azimuth are same. Just for your information, angle X is called as angle of position. If the parameters are changed, the orientation of the triangle shall change. Let's draw one more. The one coming up on the right side, getting labeled. All parts we are familiar with are getting labeled out in the diagram. What is the difference between these two triangles? Let us see the R angle. Here the R angle was EHA as already said. Here the R angle of the body is westwards of the observer, and this R angle is called as LHA. So our angle P could sometimes be LHA. On other occasions, it could be EHA. As far as angle Z is concerned, in this case, it was equal to azimuth. But out here, if you measure clockwise from north, this arc represents the azimuth of the body, whereas the internal angle of the triangle Z will be represented by this arc. So what do we see in this case? That angle Z is equal to 360 minus azimuth, or else azimuth is equal to 360 minus angle Z. So the important things here are, we'll have to determine whether P is EHA or LHA. We'll have to determine whether polar distance is 90 plus declination or 90 minus declination. And we'll have to establish the relationship between angle Z and azimuth. Let's quickly summarize how we would do that. Now, if the azimuth of the body is greater than 180 degrees, it means the body lies to the west of the observer. And if it lies to the west of the observer, obviously angle P would be equal to LHA. If the azimuth of the body is less than 180 degrees, that means the body lies to the east of the observer. In that case, angle P becomes easterly R angle. And if we are interested in LHA, then LHA will be then 360 degrees minus angle P. How do we decide on polar distance? Now, polar distance will be equal to 90 minus declination of the body if the latitude of the observer and declination of the body are same names. If they are opposite names, Px will be 90 plus declination. And lastly, let us see how azimuth gets linked to angle Z. We could have these four options. Azimuth may be equal to angle Z as in diagram to the left. Azimuth may be 360 degrees minus angle Z as in the diagram to the right. If we make the PZX triangle with the south pole, we could have the other two options also coming up, wherein azimuth may be 180 degrees minus angle Z, or azimuth may be 180 degrees plus angle Z. So based on the PZX triangle, we can decide as to what is the relationship between angle Z and the azimuth. And last thing, let's have a look at the cosine formula once again. Sine formula we have used when we are doing the great circle sailing. So what is cosine formula? Cosine of any side of the spherical triangle is equal to cosine of the opposite angle multiplied by sine of the adjacent side 1 multiplied by the sine of the adjacent side 2 plus cosine of adjacent side 1 into cosine of adjacent side.
Okay, beta, this cosine formula is in a slightly different format. We did it cos of angle is equal to cos of opposite side. So it is perfectly same. There is no difference at all. Only thing is in this, the right hand side and left hand side are slightly changed. Otherwise, the formula is exactly the same. We had taken an angle on the left hand side. They have taken a side on the left hand side. That is the only difference. Otherwise, the formula is the same. So let me show you the PZX triangle and how do we identify the star on a full diagram. So we see the full rational horizon diagram and we will understand the concept. Then after the concept is understood, we can come back and practice a couple of questions. So let's go back to the presentation. Just give me a minute, I'll set up the presentation. You have this star table in front of you now.
Yes, sir.
Now the first thing beta which you can see here is the magnitude of the star. So you get the magnitude of the star, then you have the name and number. So this number is not required for any purpose. Just mentioned here to tell you whether this star is available on the daily page also or not. Then you see the data given to you from January to June on the left hand side page. You are given the SHA and you are given the declination. As I told you, these are the degrees figures and these are the minutes figure. The SHA and declination of stars does not change much. The change is very, very slight. So you will hardly find the degrees changing. The change will always be in minutes. So for any star you can see, let us say the first star, the SHA is 5 degrees. In the month of January, 15.4 minutes. In the month of February, 15.9 minutes. Then 16 minutes and so on. The change is very, very gradual. So that's why the degrees are only given for once in the beginning. Right. Now, beta, these stars which are mentioned here, you can see the magnitude of all these stars. Let's go to the right side page. Okay, this is the right side page, the page number 269. You see the magnitude of the stars. It's mentioned here. We discussed about the variable magnitude. You can see here for Alpha Hercules, the star having a SHA of 101 was having a variable magnitude and the range is given at the bottom of the page. You can see the range given as 3.0 to 3.7. So this basically means that the magnitude of this star changes from 3.0 to 3.7 in this particular year. This is the almanac for 1992. Now, can you tell me what could be the reason for this change in magnitude, beta?
Sir, distance from the Earth may be changing.
But stars are more or less fixed objects in the universe. And if distance is changing, then it will change with every star, isn't it?
Yes, sir.
Or lagao dimag. This will not be asked to you in the returns, but sometimes they may ask you in orals.
वेदर की वजह से रिफ्लेक्शन होता है उस
ओके, वेदर चेंज हो गया, क्लाउडी, रिस्ट्रिक्टेड विजिबिलिटी, फॉग, तो बेटा सारे सारे स्टार्स का ही वो चेंज हो जाएगा मैग्नीट्यूड.
नहीं
एंड
सर, थोड़ा रिफ्लेक्शन होता है उसकी वजह से थोड़ा बहुत.
so only in the direction of this particular star there is a change in the atmosphere, huh?
नहीं सर, सबके लिए हो रहा.
Okay.
सर उसकी खुद की कुछ इंटेंसिटी मतलब होती होगी चेंज वेरिएबल, खुद की उसकी ल्यूमिनस इंटेंसिटी.
Right. Now this could be one of the reasons, beta. You see, every star has its own age. The stars are born. Black hole से एक star बनना शुरू होता है. A star is born, then the star matures. It comes to its middle age, and then it comes to its end of life, and then the star slowly starts to die. Now this could be one of the reasons, because of a difference, causing a difference in the magnitude. If a star is being born or if a star is dying, so that could lead to the brightness increasing or decreasing. But this is a very, very, very rare phenomena. Happens in millions of years, once in millions of years. Very, very rare phenomena. You know what is the age of the sun right now? It's in the young age or middle age or last age? Okay, so this is your homework. Google it and find out the age of the sun. Anyway,
सर बताए
sun,
सर, इंटरेस्टिंग क्वेश्चन है सर.
sun is in the middle, almost in the middle age, beta. It's in the middle age. It's adult, and
Okay.
still some time for it to and die. So not to worry. So anyway, this could be one of the reasons which could lead to a variable magnitude or brightness of the star. The more probable reason is, now beta, there are many objects in the space, many objects. Some are lit, emitting light like stars. Some of the objects are not emitting light at all, like planets, the satellites. They don't emit light of their own. There are many other objects also, asteroids, meteorites. So the most probable cause of variation in the brightness or magnitude of a star is that it is being obscured by some other body for a particular amount of time in that year. So if this star Alpha Hercules is being obscured by a satellite or by an asteroid or by a meteorite or any other body, it will lead to a reduction or the increase तो हो नहीं सकता है, reduction in the brightness of that star, leading to a variable magnitude. So this is the most probable cause because of which the brightness of a star could change. Okay, so anyway, that was the off-topic thing which I asked you, could be asked to you in orals. So now we are clear about the name of the stars. We are clear about the SHA and declination. It can be picked up from here. You can pick up the SHA and declination of any particular star. And this table spreads out into about 6 pages or so. And you can see the SHA going from 000 to 360. This is the last star here in the table. So Alpharats with a SHA of 357. So it gives you a list of all the possible stars which could be visible to you and which you could use for the purpose of sight taking. So any star in the sky which you see, observe for the purpose of sight taking, you will be able to find out that star here. The stars which are listed on the daily pages, you see these numbers 1, 2, 3, 4, 5, 6, 7, they indicate that these stars are listed in the daily pages of the almanac also. They are the most bright stars, and they are the ones which are most often used for sight taking purpose. So chances are if you have taken a sight, you will be picking up a bright star which is easy to see, and when you pick that up, a great chance is that you will find that star in the daily page itself. But when you enter into the daily page, just open up any daily page, beta, any date page, and look at the list of stars.
सर ये अल्फा बीटा गामा ये क्या है?
Okay, these are the names given to the stars, beta. Like you see, Alpha Hydri, this star is there. There could be another star, Beta Hydri. You see here.
यस सर.
So जब इन्होंने naming की थी stars की, sometimes if the stars were close by or in the same constellation, they named them as Alpha, Beta, Gamma, Delta that way. Okay, so they ran out of the names that time and they differentiated it with these symbols.
ओके सर.
सर सबसे पास वाला स्टार सर वो है ना अल्फा सेंचुरी.
That's right. After the sun, that is the nearest star to us. Now, have you gone to the daily page, beta? Have you opened up the daily page?
Yes, sir.
ओपन.
Okay. अब बेटा डेली पेज में जो स्टार्स की लिस्ट है, लेफ्ट हैंड साइड पेज पे राइट हैंड साइड कॉलम जो है आपका, दैट गिव्स यू द लिस्ट ऑफ स्टार्स. If you see carefully, the list is given in alphabetical order, starting from A, B, C, D, and so on.
Yes, sir.
Right. Now, if you compare it with this table does not give you the list in alphabetical order. This table gives you the list in increasing order of SHA. Right. So if you are looking for a star from a particular name, the daily page table will help you to find it quickly. But if you are looking at a star from its SHA, you are trying to identify a star from its SHA, the table on page 268 will be able to quickly identify that particular star. So this is the difference between both these tables. One, this table is complete, gives you the complete list of stars. Second, it is given in increasing order of SHA. So very easy to find a star if you know its SHA. Whereas on a daily page, you will have to search for its SHA. The SHA is random there because the stars are listed alphabetically. So that is the difference between the two tables. Okay.
सर ये जो सारे डेली पेजेस पे हैं वो सारे स्टार्स यहाँ पे दिए हुए हैं ना.
All are here, beta. All are here. All
Okay.
57 are here in this list also. This list is complete.
Okay, sir.
Okay. Okay, so this basically completes this explanation of this stars table. Now somebody talked of Alpha Centauri. This is the nearest star to us. How much distance it is from Earth, beta? Any idea? Alpha Centauri?
नहीं सर ये तो नहीं सर याद है, बस इतना ही पता है.
Okay, this Alpha Centauri is about more than 4 light years away from us. Means the distance traveled by light in 4 years. So that is the distance from Alpha Centauri, more than that distance. So to give you another insight into the universe, it is not connected with the topic at all. Let us say Alpha Centauri dies today. The star gets extinguished. Okay, let's imagine 11th of October 2021. The star Alpha Centauri died, finished off. Gas khatam ho gayi. Now, how long will you be able to see it, beta? Will it disappear from the sky today itself?
तो 4 years तक तो मतलब आएगी उसकी लाइट, क्योंकि आखिरी लाइट 4 साल तक आएगी ना.
Right. So 2025 तक आपको वो स्टार दिखता रहेगा, even though it is not there. Because आज जो लाइट आपको दिखाई दे रही है उस स्टार से, वो 4 साल पहले चलना शुरू किया था उसने. And of the remaining stars, they are even farther than that. Even farther than that. So maybe there could be a star whose light started from that particular star more than 100 years before. Okay, so it took 100 years for that light to reach us. It could be 100 light years away. So anyway, that was a off-topic point related to stars. So this basically completes the understanding of the stars table.